Okay, so now we're gonna start with the big question. How to build the server layer? What is the process? Okay, as usual, first things first, we have to analyze. And now the task before building anything in the server layer, we have to go and explore the data in order to understand the content of our sources. Once we have it, what we're gonna do, we will be starting coding. And here the transformation that we're gonna do is data cleansing. This is usually a process that takes really long time. And I usually do it in 3 steps. The first step is to check first the data quality issues that we have in the bronze layer. So before writing any data transformations, first we have to understand what are the issues. And only then I start writing data transformations in order to fix all those quality issues that we have in the bronze. And the last step, once I have clean results, what we're gonna do, we're gonna go and insert it into the server layer. And those are the 3 phases that we will be doing as we are writing the code for the server layer. And the third step, once we have all the data in the server layer, we have to make sure that the data is now correct and we don't have any quality issues anymore. And if you find any issues, of course, what you're gonna do, we're gonna go back to coding, we're gonna do the data cleansing and again check. So it is like a cycle between validating and coding. Once the quality of the server layer is good, we cannot skip the last phase where we're gonna document and commit our work in the Git. And here we're gonna have 2 new documentations. We're gonna build the data flow diagram and as well the data integration diagram after we understood the relationship between the sources from the first step. So this is the process and this is how we're gonna build the server layer. Alright, so now exploring the data in the bronze layer. So why it is very important? Because understanding the data, it is the key to make smart decisions in the server layer. It was not the focus in the bronze layer to understand the content of the data at all. We focused only how to get the data to the data warehouse. So that's why we have now to take a moment in order to explore and understand the tables and as well how to connect them. What are the relationship between these tables? And it is very important as you are learning about a new source system is to create like some kind of documentation. So now let's go and explore the sources. Okay, so now let's go and explore them one by one. We can start with the first one from the CRM. We have the customer info. So right click on it and say select top 1000 rows. And this is of course important if you have like a lot of data. Don't go and explore millions of rows. Always limit your queries. So for example, here we are using the top 1000 just to make sure that you are not impacting the system with your queries. So now let's have a look to the content of this table. So we can see that we have here customer informations. So we have an ID, we have a key for the customer, we have first name, last name, marital status, gender, and the creation date of the customer. So simply this is a table for the customer information and a lot of details for the customers. And here we have like 2 identifiers. One, it is like technical ID and another one, it's like the customer number. So maybe we can use either the ID or the key in order to join it with other tables. So now what I usually do is to go and draw like a data model or let's say integration model just to document and visual what I am understanding. Because if you don't do that, you're gonna forget it after a while. So now we go and search for a shape. Let's search for a table and I'm gonna go and pick this one over here. So here we can go and change the style. For example, we can make it rounded or you can go make it sketch and so on. And we can go and change the color. So I'm gonna make it blue, then go to the text, make sure to select the whole thing and let's make it bigger, 26. And then what I'm gonna do for those items, I'm just gonna select them and go to arrange and maybe make it 40, something like this. So now what we're gonna do, we're gonna just go and put the table name. So this is the one that we are now learning about. And what I'm gonna do, I'm just gonna go and put here the primary key. I will not go and list all the informations. So the primary key was the ID and I will go and remove all those stuff. I don't need it. Now, as you can see, the table name is not really friendly. So I can go and bring a text and put it here on top and say, this is the customer information, just to make it friendly and to not forget about it. And as well, gonna increase the size to maybe 20, something like this. Okay, with that, we have our first table. And we're gonna go and keep exploring. So let's move to the second one. We're gonna take the product information, right click on it and select the top 1000 rows. I will just put it below the previous query it. Now by looking to this table, we can see we have product informations. So we have here a primary key for the product and then we have like a key or let's say product number. And after that we have the full name of the product costs, and then we have the product line, and then we have like start and end. Well, this is interesting to understand why we have start and ends. Let's have a look, for example, for those 3 rows. All of those three having the same key, but they have different IDs. So it is the same product, but with different costs. So for 2011, we have the cost of 12, then 2012, we have 14, and for the last year, 2013, we have 13. So it's like we have like a history for the changes. So this table not only holding the current informations of the product, but also history informations of the product. And that's why we have those two dates, start and end. Now let's go back and draw this information over here. So I'm just gonna go and duplicate it. So the name of this table is gonna be the BRD info. And let's go and give it like a short description. Current and history products information. Something like this, just to not forget that we have history in this table. And here we have as well the BRD ID. And there is like nothing that we can use in order to join those two tables. We don't have like a customer ID here, or in the other table we don't have any product ID. Okay, so that's it for this table. Let's jump to the third table and the last one in the CRM. So let's go and select. I just made the other queries as well short. So let's go and execute. So what do you have over here? We have a lot of informations about the order, the sales, and a lot of measures. Order number, we have the product key. So this is something that we can use in order to join it with the product table. We have the customer ID. We don't have the customer key. So here we have like ID and here we have key. So there is like two different ways on how to join tables. And then we have here like dates, the order date, the shipping date, the due date, and then we have the sales amount, the quantity, and the price. So this is like an event table. It is transactional table about the orders and sales, and it is great table in order to connect the customers with the products and as well with the orders. So let's document this new information that we have. So the table name is the sales details. So we can go and describe it like this: transactional records about sales and orders. And now we have to go and describe how we can connect this table to the other two. So we are not using the product ID, we are using the products key. And now we need a new column over here. So you can hold Control and Enter, or you can go over here and add a new row, and the other row is going to be the customer ID. So now for the customer ID, it is easy. We can go and grab an arrow in order to connect those two tables. But for the product key, we are not using the ID. So that's why I'm just going to go and remove this one and say product key. Let's have here again a check. So this is a product key. It's not a product ID. And if we go and check the old table, the products info, you can see we are using this key and not the primary key. So what we're going to do now, we will just go and link it like this and maybe switch those two tables. So I will put the customers below. Just perfect. It looks nice. Okay, so let's keep moving. Let's go now to the other source system. We have the ERP, and the first one is ERP costs, and we have this cryptical name. Let's go and select the data. So now here it's small table and we have only three informations. So we have here something called CID, and then we have something, I think this is the birthday and the gender information. So we have here male, female, and so on. So it looks again like the customer informations, but here we have like extra data about the birthday. And now if you go and compare it to the customer table that we have from the other source system, let's go and query it. You can see the new table from the ERP don't have IDs. It has actually the customer number or the key. So we can go and join those two tables using the customer key. Let's go and document this information. So I will just go and copy paste and put it here on the right side. I will just go and change the color now, since we are now talking about different source system. And here the table name gonna be this one and the key called CID. Now in order to join this table with the customer info, we cannot join it with the customer ID. We need the customer key. That's why here we have to go and add a new row. So Control Enter, and we're gonna say customer key, and then we have to go and make a nice arrow between those two keys. So we're gonna go and give it a description, customer information, and here we have the birth date. Okay, so now let's keep going. We're gonna go to the next one. We have the ERP location. Let's go and query this table. So what do you have over here? We have the CID again, and as you can see, we have country informations. And this is of course again the customer number, and we have only this information, the country. So let's go and document this information. This is the customer location. Table name gonna be like this, and we still have the same ID. So we have here still the customer ID, and we can go and join it using the customer key. And we have to give it the description, location of customers, And we can say here the country. Okay, so now let's go to the last table and explore it. We have the ERP PX catalog. So let's go and query those informations. So what do we have here? We have like an ID, a category, a subcategory, and the maintenance. Here we have like either yes and no. So by looking to this table, we have all the categories and the subcategories of the products. And here we have like special identifier for those informations. Now the question is how to join it. So I would like to join it actually with the product informations. So let's go and check those two tables together. Okay, so in the products, we don't have any ID for the categories, but we have these informations actually in the product key. So the first 5 characters of the product key is actually the category ID. So we can use this information over here in order to join it with the categories. So we can go and describe this information like this, and then we have to go and give it a name. And then here we have the ID, and the ID could be joined using the product key. So that means for the product information, we don't need at all the product ID, the primary key. All what we need is the product key or the product number. And what I would like to do is like to group those informations in a box. So let's go grab like any boxes here on the left side and make it bigger, and then make the edges a little bit smaller. Let's remove the fill and the line. I will make a dotted line, and then let's grab another box over here and say this is the CRM, and we can go and increase the size, maybe something like 40, smaller 35, bold, and change the color to blue and just place it here on top of this box. So with that we can understand all those tables belongs to the source system CRM, and we can do the same stuff for the right side as well. Now of course we have to go and add the description here, so it's going to be the products categories. Alright, so with that we have now a clear understanding how the tables are connected to each others. We understand now the content of each table, and of course it can help us to clean up the data in the silver layer in order to prepare it. So as you can see, it is very important to take time understanding the structure of the tables, the relationship between them, before start writing any code. Alright, so with that we have now clear understanding about the sources, and with that we have as well created a data integration in the Draw.io. So with that we have more understanding about how to connect the sources. And now in the next 2 tasks we will go back to SQL, where we're gonna start checking the quality and as well doing a lot of data transformations. So let's go. Okay, so now let's have a quick look to the specifications of the server layer. So the main objective, to have clean and standardized data. We have to prepare the data before going to the gold layer, and we will be building tables inside the silver layer. And the way of loading the data from the bronze to the silver is a full load. So that means we're gonna truncate and then insert. And here we're gonna have a lot of data transformations. So we're gonna clean the data, we're gonna bring normalizations, standardizations, we're gonna derive new columns. We will be doing as well data enrichment, so a lot of things to be done in the data transformation, but we will not be building any new data model. So those are the specifications, and we have to commit ourselves to this scope. Okay, so now building the DDL script for the silver layer gonna be way easier than the bronze, because the definition and the structure of each table in the silver gonna be identical to the bronze layer. We are not doing anything new, so all what you have to do is to take the DDL script from the bronze layer and just go and search and replace for the schema. I'm just using the Notepad++ for the scripts, so I'm gonna go over here and say replace the bronze dot with silver dot, and I'm gonna go and replace all. So with that, now all the DDL is targeting the schema silver layer, which is exactly what we need. Alright, now before we execute our new DDL script for the silver, we have to talk about something called the metadata columns. They are additional columns or fields that the data engineers add to each table that don't come directly from the source systems, but the data engineers use it in order to provide extra informations for each record. Like we can add a column called create date, is when the record was loaded, or an update date, when the record got updated, or we can add the source system in order to understand the origin of the data that we have. Or sometimes we can add the file location in order to understand the lineage from which file the data come from. Those are great tools if you have data issue in your data warehouse. If there is like corrupt data and so on, this can help you to track exactly where this issue happened and when. And as well, it is great in order to understand whether I have gap in my data, especially if you are doing incremental loads. It is like putting labels on everything, and you will thank yourself later when you start using them in hard times as you have an issue in your data warehouse. So now back to our DDL scripts, and all what you have to do is to go and do the following. So for example, for the first table, I will go and add at the end one more extra column. So it starts with the prefix TWH as we have defined in the naming convention, and then underscore, let's have the create date, and the data type gonna be date time 2. And now what we can do is we can go and add a default value for it. I want the database to generate these informations automatically. We don't have to specify that in any ETL scripts. So which value? It's gonna be the get date. So each record going to be inserted in this table will get automatically a value from the current date and time. So now, as you can see, the naming convention, it is very important. All those columns comes from the source system, and only this one column comes from the data engineer of the data warehouse. Okay, so that's it. Let's go and repeat the same thing for all other tables. So I will just go and add this piece of information for each DDL. Alright, so I think that's it. All what you have to do is now to go and execute the whole DDL script for the server layer. Let's go and do that. Alright, perfect. There's no errors. Let's go and refresh the tables on the Object Explorer. And with that, as you can see, we have 6 tables for the server layer. It is identical to the bronze layer, but we have one extra column for the metadata. Alright, so now in the server layer, before we start writing any data transformations and cleansing, we have first to detect the quality issues in the bronze. Without knowing the issues, we cannot find the solution, right? We will explore first the quality issues, only then we start writing the transformation scripts. So let's go. Okay, so now what we're gonna do, we're gonna go through all the tables of the bronze layer, clean up the data, and then insert it to the server layer. So let's start with the first table, the first bronze table from the source CRM. So we're gonna go to the bronze CRM customer info. So let's go and query the data over here. Now, of course, before writing any data transformations, we have to go and detect and identify the quality issues of this table. So usually I start with the first check where we go and check the primary key. So we have to go and check whether there are nulls inside the primary key and whether there are duplicates. So now in order to detect the duplicates in the primary key, what we have to do is to go and aggregate the primary key. If we find any value in the primary key that exists more than once, that means it is not unique and we have duplicates in the table. So let's go and write a query for that. So what we're gonna do, we're gonna go with the customer ID, and then we're gonna go and count. And then we have to group up the data, so group by based on the primary key. And of course, we don't need all the results, we need only where we have an issue. So we're gonna say having count higher than 1. So we are interested in the values where the count is higher than 1. So let's go and execute it. Now, as you can see, we have issue in this table. We have duplicates because all those IDs exist more than 1 in the table, which is completely wrong. We should have the primary key unique. And you can see as well, we have 3 records where the primary key is empty, which is as well a bad thing. Now, there is an issue here. If we have only 1 null, it will not be here at the result. So what I'm gonna do, I'm gonna go over here and say or the primary key is null. Just in case if we have only 1 null, I'm still interested to see the results. So if I go and run it again, we'll get the same results. So this is a quality check that you can do on the table. And as you can see, it is not meeting the expectation. So that means we have to do something about it. So let's go and create a new query. So here what we're going to do, we can start writing the query that is doing the data transformation and the data cleansing. So let's start again by selecting the data. And execute it again. So now what I usually do, I go and focus on the issue. So for example, let's go and take one of those values and I focus on it before start writing the transformation. So we're gonna say where customer ID equal to this value. Alright, so now as you can see, we have here the issue where the ID exists 3 times, but actually we are interested only on one of them. So the question is how to pick one of those. Usually we search for a timestamp or date value to help us. So if you check the creation date over here, we can understand that this record, this one over here, is the newest one and the previous 2 are older than it. So that means if I have to go and pick one of those values, I would like to get the latest one because it holds the most fresh information. So what we have to do is we have to go and rank all those those values based on the create date and only pick the highest one. So that means we need a ranking function, and for that in Scale we have the amazing window functions. So let's go and do that. We will use the function row number over and then partition by, and here we have to divide the table by the customer ID. So we're going to divide it by the customer ID, and in order now to rank those rows, we have to sort the data by something. So order by, and as we discussed, we want to sort the data by the creation date. So create date, and we're gonna sort it descending, so the highest first, then the lowest. So let's go and do that. And now we're gonna go and give it a name, flag, last. So now let's go and execute it. Now the data is sorted by the creation date, and you can see over here that this record is the number 1, then the one that is older is 2, and the oldest one is 3. Of course, we are interested in the rank number 1. Now let's go and remove the filter and check everything. So now if you have a look to the table, you can see that on the flag we have everywhere like 1, and that's because those primary keys exist only 1, but sometimes we will not have 1, we'll have 2, 3, and so on if there is like duplicates. We can go of course and do a double check. So let's go over here and say select star from this query. We're gonna say where flag last is unequal to 1. So let's go and query it. And now we can see all the data that we don't need because they are causing duplicates in the primary key and they have like an old status. So what we're gonna do, we're gonna say equal to 1, and with that we guarantee that our primary key is unique and each value exists only once. So if I go and query it like this, you will see we will not find any duplicates inside our table, and we can go and check that of course. So let's go and check this primary key, and we're gonna say and customer ID equal to this value, and you can see it exists now only once, and we are getting the freshest data from this primary key. So with that we have defined like transformation in order to remove any duplicates. Okay, so now moving on to the next one. As you can see in our table we have a lot of values where they are like string values. Now for these string values we have to check the unwanted spaces. So now let's go and write the query that's gonna detect those unwanted spaces. So we're gonna say select this column, the first name, from our table bronze customer information. So let's go and query it. Now by just looking to the data, it's going to be really hard to find those unwanted spaces, especially if they are at the end of the word. But there is a very easy way in order to detect those issues. So what we're going to do, we're going to do a filter. So now we're going to say the first name is not equal to the first name after trimming the values. So if you use the function trim, what it's gonna do, it's gonna go and remove all the leading and trailing spaces. So the first name. So if this value is not equal to the first name after trimming it, then we have an issue. So it is very simple. Let's go and execute it. So now in the result, we will get a list of all first names where we have spaces, either at the start or at the end. So again, the expectation here is no results. And the same thing, we can go and check something else, like for example the last name. So let's go and do that over here and here. Let's go and execute it. We see in the results we have as well 17 customers where they have like space in their last name, which is not really good. And we can go and keep checking all the string values that we have inside the table. So for example the gender. So let's go and check that and execute. Now as you can see we don't have any results. That means the quality of the gender is better and we don't have any unwanted spaces. So now we have to go and write transformation in order to clean up those two columns. Now what I'm gonna do, I'm just gonna go and list all the columns in the query instead of the star. Alright, so now I have a list of all the columns that I need, and now what we have to do is to go to those two columns and start removing the unwanted spaces. So we will just use the trim. It's very simple, and give it a name, of course, the same name, and we will trim as well the last name. So let's go and query this, and with that you have cleaned up those two columns from any unwanted spaces. Okay, so now moving on, we have those two informations. We have the marital status and as well the gender. If you check the values inside those two columns, as you can see, we have here low cardinality. So we have limited numbers of possible values that is used inside those two columns. So what we usually do is to go and check the data consistency inside those two columns. So it's very simple. What we're gonna do, we're gonna do the following. We're gonna say distinct and we're gonna check the values. Let's go and do that. And now as you can see, we have only 3 possible values, either a null, F or M, which is okay. We can stay like this, of course, but we can make a rule in our project where we can say we will not be working with data abbreviations. We will go and use only friendly full names. So instead of having an F, we're gonna have like a full word female, and instead of M, we're gonna have like male, and we make it as a rule for the whole project. So each time we find the gender informations, we try to give the full name of it. So let's go and map those 2 values to a friendly one. So we're gonna go to the gender over here and say case when, and we're gonna say the gender is equal to F, then make it a female, and when it is equal to M, then map it to male. And now we have to make decision about the nulls. As you can see over here, we have nulls. So do we want to leave it as a null, or we want to use always the value unknown? So with that, we are replacing the missing values with a standard default value, or you can leave it as a null. But let's say in our project that we are replacing all the missing value with a default value. So let's go and do that. We're gonna say else. I'm gonna go with the NA, not available, or you can go with the unknown, of course. So that's for the gender information, like this, and we can go and remove the old one. And now there is one thing that I usually do in this case, where sometimes what happens, currently we are getting the capital F and the capital M, but maybe in the time something changed and you will get like lower M and lower F. So just to make sure in those cases we still are able to map those values to the correct value, what we're gonna do, we're gonna just use the function upper, just to make sure that if we get any lowercase values, we are able to catch it. So the same thing over here as well. And now one more thing that you can add as well, of course, if you are not trusting the data, because we saw some unwanted spaces in the first name and the last name, you might not trust that in the future you will get here as well unwanted spaces. You can go and make sure to trim everything just to make sure that you are catching all those cases. So that's it for now. Let's go and execute. Now, as you can see, we don't have an M and an F. We have a full word, male and female. And if we don't have a value, we don't have a null, we are getting here not available. Now we can go and do the same stuff for the marital status. You can see as well we have only 3 possibilities, the S, null and an M. We can go and do the same stuff. So I will just go and copy everything from here, and I will go and use the marital status and just remove this one from here. And now what are the possible values? We have the S, so it's gonna be single. We have an M for married, and we have as well a null, and with that we are getting the not available. So with that we are making as well data standardizations for this column. So let's go and execute it. Now, as you can see, we don't have those short values. We have a full friendly value for the status and as well for the gender. And at the same time, we are handling the nulls inside those 2 columns. So with that, we are done with those 2 columns. And now we can go to the last one, that create date. For this type of informations, we make sure that this column is a real date and not as a string or varchar. And as we defined it in the data type, it is a date, which is completely correct. So nothing to do with this column. And now the next step is that we're gonna go and write the insert statement. So how we're gonna do it, we're gonna go to the start over here and say insert into silver.srm customer info. Now we have to go and specify all the columns that should be inserted. So we're gonna go and type it. So something like this, and then we have the query over here. Let's go and execute it. So let's do that. So with that, we have inserted clean data inside the silver table. So now what we're gonna do, we're gonna go and take all the queries that we have used in order to check the quality of the bronze, and let's go and take it to another query. And instead of having bronze, we're gonna say silver. So this is about the primary key. Let's go and execute it. Perfect. We don't have any results, so we don't have any duplicates. The same thing for the next one. So the silver, and it was for the first name. So let's go and check the first name and run it. As you can see, there is no results. It is perfect. We don't have any issues. You can of course go and check the last name and run it. Again, we don't have any results over here. And now we can go and check those low cardinality columns, like for example the gender. Let's go and execute it. So as you can see, we have the not available or the unknown male and female. So perfect, and you can go and have a final look to the table, to the silver customer info. Let's go and check that. So now we can have a look to all those columns. As you can see, everything looks perfect, and you can see it is working, this metadata information that we have added to the table definition. Now it says when we have inserted all those records to the table, which is really amazing information to have a track and audit. Okay, so now by looking to this script, we have done different types of data transformations. The first one is with the first name and the last name. Here we have done trimming, removing unwanted spaces. This is one of the types of data cleansing. So we remove unnecessary spaces or unwanted characters to ensure data consistency. Now moving on to the next transformation, we have this case when. So what we have done here is data normalization, or we call it sometimes data standardization. So this transformation is type of data cleansing where we're gonna map coded values to meaningful user-friendly description. And we have done the same transformation as well to the gender. Another type of transformation that we have done as well in the same case when is that we have handled the missing values. So instead of nulls, we're gonna have not available. So handling missing data is as well type of data cleansing where we are filling the blanks by adding, for example, a default value. So instead of having an empty string or a null, we're gonna have a default value like the not available or unknown. Another type of data and transformations that we have done in this script is we have removed the duplicates. So removing duplicates is as well type of data cleansing where we ensure only one record for each primary key by identifying and retaining only the most relevant row to ensure there is no duplicates inside our data. And as we are removing the duplicates, of course, we are doing data filtering. So those are the different types of data transformations that we have done in this script. Alright, moving on to the second table in the bronze layer from the CRM, we have the product info. And of course, as usual, before we start writing any transformations, we have to search for data quality issues. And we start with the first one, we have to check the primary key. So we have to check whether we have duplicates or nulls inside this key. So what you have to do, we have to group up the data by the primary key or check whether we have nulls. So let's go and execute it. So as you can see, everything is safe. We don't have duplicates or nulls in the primary key. Now moving on to the next one, we have the product key. Here we have in this column a lot of informations. So now what we have to do is to go and split this string into two informations. So we are deriving new two columns. So now let's start with the first one is the category ID. The first 5 characters, they are actually the category ID, and we can go and use the substring function in order to extract part of a string. It needs 3 arguments. The first one gonna be the column that we want to extract from, and then we have to define the position where to extract. And since the first part is on the left side, we're gonna start from the first position, and then we have to specify the length. So how many characters we want to extract? We need 5 characters. So 1, 2, 3, 4, 5. So that's it for the category ID. Category ID, let's go and execute it. Now as you can see, we have a new column called the category ID, and it contains the first part of the string. And in our database from the other source system, we have as well the category ID. Now we can go and double check just in order to make sure that we can join data together. So we're gonna go and check the ID from the bronze table, ERP, and this is gonna be from the category. So in this table, we have the category IDs, and you can see over here, those are the IDs of the category, and in the gold layer, we have to go and join those two tables. But here we still have an issue. We have here an underscore between the category and the subcategory, but in our table, we have actually a minus. So we have to replace that with an underscore in order to have matching informations between those two tables. Otherwise, we will not be able to join the tables. So we're going to use the function replace. And what we are replacing the minus with an underscore. Something like this. And if you go now and execute it, we will get an underscore exactly like the other table. And of course, we can go and check whether everything is matching by having very simple query where we say this new information not in, and then we have this nice subquery. So we are trying to find any category ID that is not available in the second table. So let's go and execute it. Now, as you can see, we have only one category that is not matching. We are not finding it in this table, which is maybe correct. So if you go over here, you will not find this category. I might just make it a little bit bigger. So we are not finding this one category from this table, which is fine. So our check is okay. Okay, so with that, we have the first part. Now we have to go and extract the second part, and we're going to do the same thing. So we're going to use the substring and the 3 argument, the product key. But this time we will not start cutting from the first position. We have to be in the middle. So 1, 2, 3, 4, 5, 6, 7. So we start from the position number 7. And now we have to define the length, how many characters to be extracted. But if you look over here, you can see that we have different length of the product keys. It is not fixed like the category ID. So we cannot go and here specify number. We have to make something dynamic. And there is a trick in order to do that. We're going to go and use the length of the whole column. With that, we make sure that we are always getting enough characters to be extracted, and we will not be losing any informations. So we will make it dynamic like this. We will not have it as a fixed length. And with that, we have the product key. So let's go and execute it. As you can see, we are now extracting the second part from this string. Now, why we need the product key? We need it in order to join it with another table called sales details. So let's go and check the sales details. So let me just check the column name. It is SLS product key. So from bronze CRM sales. Let's go and check the data over here, and it looks wonderful. So actually we can go and join those informations together, but of course we can go and check that. So we're gonna say where, and we're gonna take our new column and we're gonna say not in the subquery, just to make sure that we are not missing anything. So let's go and execute. So it looks like we have a lot of products that don't have any orders. Well, I don't have nice feelings about it. Let's go and try something like this one here. And we say where SLS PRD key like this value over here. So I'll just cut the last 3 just to search inside this table. So we really don't have such a keys. Let me just cut the second one. So let's go and search for it. We don't have it as well. So anything that starts with the F key, we don't have any order with the product where it starts with the F key. So let's go and remove it, but still we are able to join the tables, right? So if I go and say in instead of not in, so with that you are able to match all those products. So that means everything is fine actually. It's just products that don't have any orders. So with that, I'm happy with this transformation. Now moving on to the next one, we have here the name of the product. We can go and check whether there is unwanted spaces. So let's go to our quality checks, make sure to use the same table, and we're going to use the product name and check whether we find any unmatching after trimming. So let's go and do it. Well, it looks really fine, so we don't have to trim anything. This column is safe. Now moving on to the next one, we have the costs. So here we have numbers and we have to check the quality of the numbers. So what we can do, we can check whether we have nulls or negative numbers. So negative costs or negative prices, which is not realistic, depend on the business of course. So let's say in our business, we don't have any negative costs. So it's gonna be like this. Let's go and check whether it's something less than 0 or whether we have costs that is null. So let's go and check those informations. Well, as you can see, we don't have any negative values, but we have nulls. So we can go and handle that by replacing the null with a 0. Of course, if the business allow that. So in SQL Server, in order to replace the null with a 0, we have a very nice function called isNull. So we are saying if it is null, then replace this value with a 0. It is very simple, like this. And we give it a name, of course. So let's go and execute it. And as you can see, we don't have any more nulls. We have 0, which is better for the calculations if you are later doing any aggregate functions like the average. Now, moving on to the next one, we have the product line. This is again abbreviation of something, and the cardinality is low. So let's go and check all possible values inside this column. So we're just going to use the distinct, going to be BRD line. So let's go and execute it. And as you can see, the possible values are null, MRST. And again, those are abbreviations, but in our data warehouse, we have decided to give full nice names. So we have to go and replace those codes, those abbreviations, with a friendly value. And of course, in order to get those informations, I usually go and ask the expert from the source system or an expert from the process. So let's start building our case win, and then let's use the upper and as well the trim just to make sure that we are having all the cases. So the BRD line is equal to, so let's start with the first value, the M. Then we will get the friendly value. It's going to be mountain. Then to the next one, so I will just copy and paste here. If it is an R, then it is road. And another one for, let me check, what do we have here? We have MR and then S. The S stands for other sales. And we have the T. So let's go and get the T. So the T stands for touring. We have at the end an else for unknown, not available. So we don't need any nulls. So that's it. And we're gonna name it as before. So product line. So let's remove the old one and let's execute it. And as you can see, we don't have here anymore those shortcuts and the abbreviations. We have now full friendly value, but I will go and have here like capital O. It looks nicer. So with that, we have nice friendly value. Now, by looking to this case win, as you can see, it is always like we are mapping one value to another value, and we are repeating all time, upper time, and so on. We have here a quick form in the case win if it is just a simple mapping. So the syntax is very simple. We say case, and then we have the column. So we are evaluating this value over here, and then we just say when without the equal. So if it is an M, then make it mountain. The same thing for the next one, and so with that we have the functions only once, and we don't have to go and keep repeating the same function over and over. And this one only if you are mapping values, but if you have complex conditions, you cannot do it like this. But for now, I'm gonna stay with the quick form of the case win. It looks nicer and shorter. So let's go and execute it. We will get the same results. Okay, so now back to our table. Let's go to the last two columns. We have the start and end dates. So it's like defining an interval. We have start and end. So let's go and check the quality of the start and end dates. We're gonna go and say select star from our bronze table. And now we're gonna go and search it like this. We are searching for the end date that is smaller than the start. So BRD start dates. So let's go and query this. So you can see the start is always like after the end, which makes no sense at all. So we have here data issue with those two dates. So now for this kind of data transformations, what I usually do is I go and grab few examples and put it in Excel and try to think about how I'm gonna go and fix it. So here I took like two products, this one and this one over here. And for that we have like 3 rows for each one of them. And we have this situation over here. So the question now, how are we gonna go and fix it? I will go and make like a copy of one solution where we're gonna say it's very simple. Let's go and switch the start date with the end date. So if I go and grab the end date and put it at the start, things gonna look way nicer, right? So we have the start is always younger than the end. But my friends, the data now makes no sense because we say it starts from 2007 and ends by 2011. The price was 12, but between 2008 and 2012, we have 14, which is not really good because if you take, for example, the year 2010, for 2010, it was 12 and at the same time 14. So it is really bad to have an overlapping between those two dates. It should start from 2007 and end with 11 and then start maybe from 12 and end with something else. There should be no overlapping between years. So it's not enough to say the start should be always smaller than the end, but as well the end of the first history should be younger than the start of the next record. This is as well a rule in order to have no overlapping. This one has no start but has already an end, which is not really okay because we have always to have a start. Each new record in historizations has to have a start. So for this record over here, this is as well wrong. And of course, it is okay to have the start without an end. So in this scenario, it's fine because this indicate this is the current informations about the costs. So again, this solution is not working at all. So now for the solution 2, what we can say, let's go and ignore completely the end date and we take only the start dates. So let's go and paste it over here. But now we go and rebuild the end date completely from the start date, following the rules that we have defined. So the rule says the end of date of the current records comes from the start date from the next record. So here this end date comes from this value over here, from the next record. So that means we take the next start date and put it at the end date for the previous record. So with that, as you can see, it is working. The end date is higher than the start date. And as well, we are making sure this date is not overlapping with the next record. But as well, in order to make it way nicer, we can subtract it with 1. So we can take the previous day like this. So with that, we are making sure the end date is smaller than the next start. And now for the next record, this one over here, the end date gonna come from the next start date. So we will take this one for here and put it as an end date and subtract it with 1. So we will get the previous day. So now if you compare those two, you can see it's still higher than the start. And if you compare it with the next record, this one over here, it is still smaller than the next one. So there is no overlapping. And now for the last record, since we don't have here any informations, it will be a null, which is totally fine. So as you can see, I'm really happy with this scenario over here. Of course, you can go and validate this with an expert from the source system. Let's say I've done that and they approved it. And now I can go and clean up the data using this new logic. So this is how I usually brainstorm about fixing an issues. If I have like a complex stuff, I go and use Excel and then discuss it with the expert using this example. It's way better than showing a database, queries, and so on. It just makes things easier to explain and as well to discuss. So now how I usually do it, I usually go and make a focus on only the columns that I need and take only 1-2 scenarios while I'm building the logic, and once everything is ready, I go and integrate it in the query. So now I'm focusing only on these columns and only for these products. So now let's go and build our logic. Now in SQL, if you are at specific record and you want to access another information from another record, and for that we have 2 amazing window functions. We have the lead and lag. In this scenario, we want to access the next record. That's why we have to go with the function lead. So let's go and build it. Lead. And then what do we need? We need the lead of the start date. So we want the start date of the next record. And then we say over, and we have to partition the data. So the window gonna be focusing on only one product, which is the product key and not the product ID. So we are dividing the data by product key. And now of course we have to go and sort the data. So order by, and we are sorting the data by the start date and ascending, so from the lowest to the highest. And let's go and give it another name. So as, and let's say test, for example, just to test the data. So let's go and execute. And I think I missed something here. It is partition by. So let's go and execute again. And now let's go and check the results for the first partition over here. So the start is 2011 and the end is 2012. And this information came from the next record. So this data is moved to the previous record over here, and the same thing for this record. So the end date comes from the next record. So our logic is working, and the last record over here is null because we are at the end of the window and there is no next data. That's why we will get null, and this is perfect, of course. So it looks really awesome, but what is missing is we have to go and get the previous day, and we can do that very simply using -1. We are just subtracting 1 day, so we have no overlapping between those 2 dates, and the same thing for those 2 dates. So as you can see, we have just built a perfect end date, which is way better than the original data that we got from the source system. Now let's take this one over here and put it inside our query. So we don't need the end date, we need our new end date. We'll just remove that test and execute. Now it looks perfect. Alright, now we are not done yet with those 2 dates. Actually, we are saying all time dates because we don't have here any informations about the time, always 0. So it makes no sense to have these informations inside our data. So what we can do a very simple cast, and we make this column as a date instead of date time. So this is for the first one. and as well for the next one as dates. So let's try that out. And as you can see, it is nicer. We don't have the time informations. Of course, we can tell the source systems about all those issues, but since they don't provide the time, it makes no sense to have date and time. Okay, so it was a long run, but we have now a cleaned product informations, and this is way nicer than the original product information that we got from the source CRM. So if you grab the DDL of the server table, you can see that we don't have a category ID. So we have product ID and product key, and as well those two columns we just changed the data type. So it's date time here, but we have changed that to a date. So that means we have to go and do few modifications to the DDL. So what we're gonna do, we're gonna go over here and say category ID, and I will be using the same data type. And for the start and the end, this time it's gonna be date and not date and time. So that's it for now. Let's go and execute it in order to repair the DDL. And this is what happened in the silver layer. Sometimes we have to adjust the metadata if the quality of the data types and so on is not good, or we are building new derived informations in order later to integrate the data. So it will be like very close to the bronze layer, but with few modifications. So make sure to update your DDL scripts. And now the next step is that we're gonna go and insert the data into the table. And now the next step, we're gonna go and insert the result of this query that is cleaning up the bronze table into the silver table. So as we've done it before, insert into silver the product info, and then we have to go and list all the columns. I've just prepared those columns, so with that we can go and now run our query in order to insert the data. So now as you can see, SQL did insert the data, and the very important step is now to check the quality of the silver table. So we go back to our data quality checks and we go switch to the silver. So let's check the primary key. There is no issues, and we can go and check, for example, here the trims. There is as well no issue. And now let's go and check the costs. It should not be negative or null, which is perfect. Let's go and check the data standardizations. As you can see, they are friendly and we don't have any nulls. And now, very interesting, the order of the dates. So let's go and check that. As you can see, we don't have any issues. And finally, what I do, I go and have a final look to the silver table. And as we can see, everything is inserted correctly in the correct columns. So all those columns comes from the source system. And the last one is automatically generated from the DDL, indicate when we loaded this table. Now let's sit back and have a look to our script. What are the different types of data transformations that we have done here? Is, for example, over here, the category ID and the product key, we have derived new columns. So it is when we create a new column based on calculations or transformations of an existing one. So sometimes we need columns only for analytics, and we cannot each time go to the source system and ask them to create it. So instead of that, we derive our own columns that we need for the analytics. Another transformation we have is the is null over here. So we are handling here missing information. Instead of null, we're gonna have a 0. And one more transformation we have over here for the product line. We have done here data normalization. Instead of having a code value, we have a friendly value. And as well, we have handled the missing data. For example, over here, instead of having a null, we're gonna have not available. Alright, moving on to another data transformation, we have done data type casting. So we are converting the data type from one to another. And this considered as well to be a data transformation. And now moving on to the last one, we are doing as well data type casting. But what's more important, we are doing data enrichment. This type of transformation, it's all about adding value to your data. So we are adding a new relevant data to our data sets. So those are the different types of data transformations that we have done for this table. Okay, so let's keep going. We have the sales details, and this is the last table in the CRM. So what do you have over here? We have the order number, and this is a string. Of course, we can go and check whether we have an issue with the unwanted spaces. So we can search whether we're gonna find something. So we can say trim and something like this, and let's go and execute it. So we can see that we don't have any unwanted spaces. That means we don't have to transform this column, so we can leave it as it is. Now the next two columns, they are like keys and IDs in order to connect it with the other tables. As we learned before, we are using the product key in order to connect it with the product informations, and we are connecting the customer ID with the customer ID from the customer info. So that means we have to go and check whether everything is working perfectly. So we can go and check the integrity of those columns, where we say the product key not in, and then we make a subquery, and this time we can work with the silver layer, right? So we can say the product key from silver.product.info. So let's go and query this. And as you can see, we are not getting any issue. That means all the product keys from the sales details can be used and connected with the product info. The same thing, we can go and check the integrity of the customer ID, and we can use not the product. We can go to the customer info, and the name was CST ID. So let's go and query that. And the same thing, we don't have here any issues. So that means we can go and connect the sales with the customers using the customer ID, and we don't have to do any transformations for it. So things looks really nice for those three columns. Now we come to the challenging one. We have here the dates. Now those dates are not actual dates, they are integer. So those are numbers, and we don't want to have it like this. We would like to clean that up. We have to change the data type from integer to a date. Now if you want to convert an integer to a date, we have to be careful with the values that we have inside each of those columns. So now let's check the quality, for example, of the order date. Let's say where order date is less than 0, for example, something negative. Well, we don't have any negative values, which is good. Let's go and check whether we have any zeros. Well, this is bad. So we have here a lot of zeros. Now what we can do, we can replace those informations with a null. We can use, of course, the null if function like this. We can say null if, and if it is 0, then make it null. So let's execute it. And as you can see now, all those informations are null. Now let's go and check again the data. So now this integer has the year's information at the start, then the months, and then the day. So here we have to have like 1, 2, 3, 4, 5. So the length of each number should be 8. And if the length is less than 8 or higher than 8, then we have an issue. Let's go and check that. So we're going to say or length sales order is not equal to 8. That means less or higher. Let's go and execute it. Now let's go and check the results over here. And those two informations, they don't look like a date. So we cannot go and make from these informations a real date. They are just bad data quality. And of course, you can go and check the boundaries of a date. Like for example, it should not be higher than, for example, let's go and get this value 2050 and then any for the month and the date. So let's go and execute it. And if we just remove those informations just to make sure, so we don't have any date that is outside of the boundaries that you have in your business. Or you go, for example, and say the boundary should be not less than, depend when your business started, maybe something like this. We are getting, of course, those values because they are less than a null, but if you have values around this date, you will get it as well in the query. So we can go and add the rests. So all those checks like validate the column that has date informations and it has the data type integer. So again, what are the issues over here? We have zeros, and sometimes we have like strange numbers that cannot be converted to a date. So let's go and fix that in our query. So we can say case when the sales order, the order date is equal to 0, or of the order date is not equal to 8, then null, right? We don't want to deal with those values. They are just wrong and they are not real dates. Otherwise, we say else, it's gonna be the order date. Now what we're gonna do, we're gonna go and convert this to a date. We don't want this as an integer. So how we can do that? We can go and cast it first to a varchar, because we cannot cast from integer to date in SQL Server. First, you have to convert it to a varchar, and then from varchar, you go to a date. Well, this is how we do it in SQL Server. So we cast it first to a varchar, and then we cast it to a date, like this. That's it. So we have end, and we are using the same column name. So this is how we transform an integer to a date. So let's go and query this. And as you can see, the order date now is a real date. It is not a number. So we can go and get rid of the old column. Now we have to go and do the same stuff for the shipping date. So we can go over here and replace everything with the shipping date, and let's go and query. Well, as you can see, the shipping date is perfect. We don't have any issue with this column, but still I don't like that we found a lot of issues with the order date. So what we're gonna do, just in case this happens for the shipping date in the future, I will go and apply the same rules to the shipping dates. So let's take the shipping date like this. And if you don't want to apply it now, you have always to build like quality checks that runs every day in order to detect those issues. And once you detect it, then you can go and do the transformations. But for now, I'm gonna apply it right away. So that is for the shipping date. Now we go to the due date and we will do the same tests. Let's go and execute it. And as well, it is perfect. So still, I'm gonna apply the same rules. So let's get the due date everywhere here in the query. Just make sure you don't miss anything here. So let's go and execute. Now, perfect. As you can see, we have the order date, shipping date, and due date. And all of them are date and don't have any wrong data inside those columns. Now, still there is one more check that we can do, and if that's the order date should be always smaller than the shipping date or the due date. Because it makes no sense, right? If you are delivering an item without an order. So first the order should happen, then we are shipping the items. So there is like an order of those dates and we can go and check that. So we are checking now for invalid date orders where we're gonna say the order date is higher than the shipping date, or we are searching as well for an order where the order date is higher than the due date. So we can have it like this, due date. So let's go and check. Well, that's really good. We don't have such a mistake on the data and the quality looks good. So the order date is always smaller than the shipping date or the due date. So we don't have to do any transformations or cleanup. Okay, friends, now moving on to the last three columns. We have the sales, quantity, and the price. All those informations are connected to each other. So we have a business rule or calculation. It says the sales must be equal to quantity multiplied by the price. And all sales, quantity, and price informations must be positive numbers. So it's not allowed to be negative, zero, or a null. So those are the business rules, and we have to check the data consistency in our table. Does all those three informations following our rules? So we're gonna start first with our rule, right? So we're gonna say if the sales is not equal to quantity multiplied by the price. So we are searching where the result is not matching our expectation. And as well, we can go and check other stuff like the nulls. So for example, we can say or sales is null or quantity is null. And the last one for the price. And as well, we can go and check whether they are negative numbers or zero. So we can go over here and say less or equal to zero and apply it for the other columns as well. So with that, we are checking the calculation, and as well we are checking whether we have null, zero, or negative numbers. Let's go and check our informations. I'm gonna have here a distinct. So let's go and query it. And of course we have here bad data, but we can go and sort the data by the sales, quantity, and the price. So let's do it. Now, by looking to the data, we can see in the sales we have nulls, we have negative numbers, and zeros. So we have all bad combinations, and as well we have here bad calculations. So as you can see, the price here is 50, the quantity is 1, but the sales is 2, which is not correct. And here we have as well wrong calculations. Here we have to have a 10 and here 9, or maybe the price is wrong. And by looking to the quantity now, you can see we don't have any nulls, we don't have any zeros or negative numbers, so the quantity looks better than the sales. And if you look to the prices, we have nulls, we have negatives, and yeah, we don't have zeros. So that means the quality of the sales and the price is wrong, the calculation is not working, and we have these scenarios. Now, of course, how I do it here, I don't go and try now to transform everything on my own. I usually go and talk to an expert, maybe someone from the business or from the source system, and I show those scenarios and discuss. And usually there is like two answers. Either they're gonna tell me, you know what, I will fix it in my source, so I have to live with it. There is incoming bad data, and the bad data gonna be presented in the warehouse until the source system clean up those issues. And the other answer you might get, you know what, we don't have the budget and those data are really old and we are not going to do anything. So here you have to decide, either you leave it as it is, or you say, you know what, let's go and improve the quality of the data. But here you have to ask for the experts to support you solving these issues, because it really depends on the rules. Different rules makes different transformations. So now let's say that we have the following rules. If the sales informations are null or negative or zero, then use the calculation, the formula, by multiplying the quality with the price. And now if the prices are wrong, for example, we have here a null or zero, then go and calculate it from the sales and the quantity. And if you have a price that is a minus, like minus 21, a negative number, then you have to go and convert it to a 21. So from a negative to a positive without any calculations. So those are the rules, and now we're gonna go and build the transformations based on those rules. So let's do it step by step. I will go over here and we're gonna start building the new sales. So what is the rule says? Case when, of course, as usual, if the sales is null, or let's say the sales is negative number or equal to 0. Or another scenario, we have sales information, but it is not following the calculation. So we have wrong information in the sales. So we're going to say the sales is not equal to the quantity multiplied by the price. But of course, we will not leave the price like this by using the function APS. The absolute, it's gonna go and convert everything from negative to a positive. Then what we have to do is to go and use the calculation. So it's gonna be the quantity multiplied by the price. So that means we are not using the value that's come from the source system, we are recalculating it. Now let's say the sales is correct and not one of those scenarios. So we're gonna say else. We will go with the sales as it is. That comes from the source because it is correct. It's really nice. Let's go and say an end and give it the same name. I will go and rename the old one here as an old value, and the same for the price. The quantity will not touch it because it is correct, so like this. And now let's go and transform the prices. So again, as usual, we go with case when. So what are the scenarios? The price is null or the price is less or equal to 0. Then what we're gonna do? We're gonna do the calculation. So it's gonna be the sales divided by the quantity, the SLS quantity. But here we have to make sure that we are not dividing by 0. Currently we don't have any zeros in the quantity, but you don't know in the future you might get a 0 and the whole code gonna break. So what you have to do is to go and say, if you get any 0, replace it with a null. So null if it is 0, then make it null. So that's it. Now if the price is not null and the price is not negative or equal to 0, then everything is fine. And that's why we're gonna have now the else. It's gonna be the price as it is from the source system. So that's it. We're gonna say end as price. So I'm totally happy with that. Let's go and execute it and check, of course. So those are the old informations and those are the new transformed, cleaned up informations. So here previously we have a null, but now we have 2. So 2 multiplied with 1, we are getting 2. So the sales is here correct. Now moving on to the next one, we have in the sales 40, but the price is 2. So 2 multiplied with 1, we should get 2. So the new sales is correct, it is 2 and not 40. Now to the next one over here, the old sales is 0, but if you go and multiply the 4 with the quantity, you will get 4. So the sales here is not correct. That's why in the new sales, we have it correct as a 4. And let's go and get a minus. So in this case, we have a minus, which is not correct. So we are getting the price multiplied with 1. We should get here a 9, and this sales here is correct. Now let's go and get a scenario where the price is a null, like this here. So we don't have here a price, but we calculated from the sales and the quantity. So we divided the 10 by 2 and we have 5. So the new price is better. And the same thing for the minuses. So we have here minus 21 and in the output we have 21, which is correct. So for now, I don't see any scenario where the data is wrong. So everything looks better than before. And with that, we have applied the business rules from the experts and we have cleaned up the data in the data warehouse. And this is way better than before because we are presenting now better data for analysis and reporting, but it is challenging and you have exactly to understand the business. So now what we're going to do, we're going to go and copy those informations and integrate it in our query. So instead of sales, we're going to get our new calculation, and instead of the price, we will get our correct calculation. And here I'm missing the end. Let's go and run the whole thing again. So with that, we have as well now cleaned sales, quantity, and price, and it is following our business rules. So with that, we are done cleaning up the sales details. The next step, we're going to go and insert it to the sales details, but we have to go and check again the DDL. So now all what you have to do is to compare those results with the DDL. So the first one is the order number, it's fine, the product key, the customer ID, but here we have an issue. All those informations now are date and not an integer, so we have to go and change the data type. And with that, we have better data type than before. Then the sales quantity price, it is correct. Let's go and drop the table and create it from scratch again. And don't forget to update your DDL script. So that's it for this. And we're going to go now and insert the results into our silver table, sales details. And we have to go and list now all the columns. I have already prepared the list of all the columns. So make sure that you have the correct order of the columns. So let's go now and insert the data. And with that, we can see that, the SQL did insert data to our sales details. But now very important is to check the health of the silver table. So what we're gonna do, instead here of bronze, we're gonna go and switch it to silver. So let's check over here. So here always the order is smaller than the shipping and the due date, which is really nice. But now I'm very interested on the calculations. So here we're gonna switch it from bronze to silver, and I'm gonna go and get rid of all those calculations because we don't need it. This, and now let's see whether we have any issue. Well, perfect. Our data is following the business rules. We don't have any nulls, negative values, zeros. Now, as usual, the last step, the final check. We will just have a final look to the table. So we have the order number, the product key, the customer ID, those 3 dates. We have the sales, quantity, and the price. And of course, we have our metadata column. Everything is perfect. So now by looking to our code, what are the different types of data transformations that we are doing? So on those 3 columns, we are doing the following. So at the start, we are handling invalid data. And this is as well type of transformation. And as well at the same time, we are doing data type casting. So we are changing it to more correct data type. And if you are looking to the sales over here, then what we are doing over here is we are handling the missing data and as well the invalid data by deriving the column from already existing one. And it is as well very similar for the price. We are handling as well the invalid data by deriving it from specific calculation over here. So those are the different types of data transformations that you have done in this script. Alright, now let's keep moving to the next source system. We have the customer AZ12. So here we have like only 3 columns. And let's start with the ID first. So here again we have the customer's informations. And if we go and check again our model, you can see that we can connect this table with the CRM table customer info using the customer key. So that means we have to go and make sure that we can go and connect those 2 tables. So let's go and check the other table. We can go and check, of course, the server layer. So let's query it, and we can query both of the tables. Now we can see there is here like extra characters that are not included in the customer key from the CRM. So let's go and search, for example, for this customer over here, where CID, like, so we are searching for a customer has similar ID. Now, as you can see, we are finding this customer, but the issue is that we have those 3 characters in AS. There is no specifications or explanation why we have the NAS. So actually what we have to do is to go and remove those informations. We don't need it. So let's again check the data. So it looks like the old data have an NAS at the start, and then afterward we have new data without those 3 characters. So we have to clean up those IDs in order to be able to connect it with other tables. So we're gonna do it like this. We're gonna start with the case when, since we have like 2 scenarios in our data. So if the CID is like the 3 characters in AS, so if the ID start with those 3 characters, then we're gonna go and apply transformation function. Otherwise, it's gonna stay like it is. So that's it. So now we have to go and build the transformation. So we're gonna use substring, and then we have to define the string. It's gonna be the CID, and then we have to define the position where it starts cutting or extracting. So we can say 1, 2, 3, and then 4. So we have to define the position number 4, and then we have to define the string, how many characters should be extracted. I will make it dynamic, so I will go with the length. I will not go and count how much. So we're gonna say the CID. So it looks good. If it's like NAS, then go and extract from the CID at the position number 4 the rest of the characters. So let's go and execute it. And I'm missing here a comma again, where we don't have any NAS at the start. And if you scroll down, you can see those as well are not affected. So with that, we have now a nice ID to be joined with the other table. Of course, we can go and test it like this, where and then we take the whole thing, the whole transformation, and say not in. We remove, of course, the alias name. We don't need it. And then we make very simple substring select distinct CST key, the customer key, from the silver table. It can be silver CRM cost info. So that's it. Let's go and check. So as you can see, it is working fine. So we are not able to find any unmatching data between the customer info from ERP and the CRM. But of course, after the transformation, if you don't use the transformation, so if I just remove it like this, we will find a lot of unmatching data. So this means our transformation is working perfectly and we can go and remove the original value. So that's it for the first column. Okay, now moving on to the next field, we have the birthday of the customers. So the first thing to do is to check the data type. It is a date. So it's fine. It is not an integer or a string. So we don't have to convert anything, but still there is something to check with the birth date. So we can check whether we have something out of range. So for example, we can go and check whether we have really old dates at the birth dates. So let's take 1900 and let's say 24, and we can take the first date of the month. So let's go and check that. Well, it looks like that we have customers that are older than 100 years. Well, I don't know, maybe this is correct, but it sounds, of course, strange, the bit of the business, of course.
Hey, this is Creed, and he is in charge of something,
That is correct.
Say hi to the kids.
Hi, kids.
Yay!
And then we can go and check the other boundary where it is almost impossible to have a customer that the birthday is in the future. So we can say birth date is higher than the current date. Like this. So let's go and query this information. Well, it will not work because we have to have like an OR between them. And now if we check the list over here, we have dates that are invalid for the birth dates. So all those dates, they are all birthday in the future, and this is totally unacceptable. So this is an indicator for bad data quality. Of course, you can go and report it to the source system in order to correct it. So here it's up to you what to do with those dates. Either leave it as it is as a bad data, or we can go and clean that up by replacing all those dates with a null, or maybe replacing only the one that is extreme, where it is 100% is incorrect. So let's go and write the transformation for that. As usual, we're gonna start with case when birth date is larger than the current date and time, then null. Otherwise, we can have an else where we have the birth date as it is, and then we have an end as birth date. So let's go and execute it. And with that, we should not get any customer where the birthday in the future. So that's it for the birth date. Now let's move to the next one. We have the gender. Now again, the gender information is low cardinalities. So we have to go and check all the possible values inside this column. So in order to check all the possible values, we're going to use select distinct gen from our table. So let's go and execute it. And now the data doesn't look really good. So we have here a null, we have an F, we have here an empty string, we have male, female, and again we have the M. So this is not really good. What we're gonna do, we're gonna go and clean up all those informations in order to have only 3 values: male, female, and not available. So we're gonna do it like this. We're gonna say case when, and now we're gonna go and trim the values just to make sure there is like no empty spaces. And as well, I'm gonna go and use the upper function just to make sure that in the future, if we get any lower cases and so on, we are covering all the different scenarios. So case, this is in F4, let's say female, then make it as female. And we can go and do the same thing for the male, like this. So if it is an M or a male, make sure it is capital letters because here we are using the upper, then it is a male. Otherwise, all other scenarios, it should be not available. So whether it is an empty string or nulls and so on. So we have to have an end, of course, as gen. So now let's go and test it and check whether we have covered everything. So you can see the M is now male, the empty is not available, the F is female, the empty string or maybe spaces here is not available. Female gonna stay as it is, and the same for the male. So with that, we are covering all the scenarios and we are following our standards in the project. So I'm gonna go and cut this and put it in our original query over here. So let's go and execute the whole thing. And with that, we have cleaned up all those 3 columns. Now the question is, did we change anything in the DDL? Well, we didn't change anything. We didn't introduce any new column or change any data type. So that means the next step is we're gonna go and insert it in the server layer. So as usual, we're gonna say here, insert into silver ERP the customer, and then we're gonna go and list all the column names. So CID, birth date, and the gender. All right, so let's go and execute it. And with that, we can see it inserted all the data. And of course, the very important step as the next is to check the data quality. So let's go back to our query over here and change it from bronze to silver. So let's go and check the silver layer. Well, of course, we are getting those very old customers, but we didn't change that. We only change the birthday that is in the future, and we don't see it here in the results. So that means everything is clean. So for the next one, let's go and check the different genders. And as you can see, we have only those 3 values. And of course, we can go and take a final look to our table. So you can see the CID here, the birth date, gender, and then we see our metadata column. And everything looks amazing. So that's it. What are the different types of data transformations that we have done? First, with the ID, what we have done, we have handled invalid values. So we have removed this part where it is not needed. And the same thing goes for the birth dates. We have handled as well invalid values. And then for the last one, for the gender, we have done data normalizations by mapping the code to more friendly value. And as well, we have handled the missing values. So those are the types that we have done in this code. Okay, moving on to the second table, we have the location informations. So we have ERP location A101. So now here the task is easy because we have only 2 columns. And if you go and check the integration model, we can find our table over here. So we can go and connect it together with the customer info from the other system using the CIID with the customer key. So those 2 informations must be matching in order to join the tables. So that means we have to go and check the data. So let's go and select the data, CST key from, let's go and get the silver data, customer info. So let's go. Now if you go and check the result, you can see over here that we have an issue with the CIID. There is like a minus between the characters and the numbers, but the customer ID, the customer number, we don't have anything that splits the characters with the numbers. So if you go and join those 2 informations, it will not be working. So what we have to do, we have to go and get rid of this minus because it is totally unnecessary. So let's go and fix that. It's going to be very simple. So what we're going to do, we're going to say CIID. So we're going to go and search for the minus and replace it with nothing. It's very simple like this. So let's go and query it again. And with that, things looks very similar to each other's. And as well, we can go and query it. So we're going to say where our transformation is not in, then we can go and use this as a subquery like this. So let's go and execute it. And as you can see, we are not finding any unmatching data now. So that means our transformation is working. And with that, we can go and connect those 2 tables together. So if I take the transformation away, you can see that we will find a lot of unmatching data. So the transformation is okay. We're going to stay with it. And now let's speak about the countries. Now we have here multiple values and so on. What I'm going to do, this is low cardinality, and we have to go and check all possible values inside this column. So that means we are checking whether the data is consistent. So we're going to do it like this, distinct the country from our table. I'm just going to go and copy it like this. And as well, I'm going to go and sort the data by the country. So let's go and check the informations. Now you can see we have a null, we have an empty string, which is really bad. And then we have a full name of country. And then we have as well an abbreviation of the countries. Well, this is a mix. This is not really good because sometimes we have DE and sometimes we have Germany. And then we have the United Kingdom. And then for the United States, we have like 3 versions of the same information, which is as well not really good. So the quality of the country is not really good. So let's go and work on the transformation. As usual, we're going to start with the case when. If trim country is equal to DE, then we're going to transform it to Germany. And the next one, it's going to be about the USA. So if trim country is in, so now let's go and get those 2 values, the US and the USA. So US and USA, then it's going to be the United States. So with that, we have covered as well those 3 cases. Now we have to talk about the null and the empty string. So we're going to say when trim country is equal to empty string or country is null, then it's going to be not available. Otherwise, I would like to get the country as it is. So trim country, just to make sure that we don't have any leading or trailing spaces. So that's it. Let's go and say this is the country. So it is working and the country information is transformed. And now what I'm going to do, I'm going to take the whole new transformation and compare it to the old one. Let me just call this as old country, and let's go and query it. So now we can check those values state as before. So nothing did change. The DE is now Germany. The empty string is not available, the null the same thing, and the United Kingdom stayed as it's like before, and now we have one value for all those information, so it's only the United States. So it looks perfect, and with that we have cleaned as well the second column. So with that we have now clean results, and now the question, did we change anything in the DDL? Well, we haven't changed anything. Both of them are varchar, so we can go now immediately and insert it into our table. So insert into silver customer location, and here we have to specify the columns. It's very simple, the ID and the country. So let's go and execute it, and as you can see we got now inserted all those values. Of course, as a next we go and double check those informations. I will just go and remove all those stuff as well here, and instead of bronze let's go with the silver. So as you can see all the values of the country looks good, and let's have a final look to the table. So like this, so we have the IDs without the separator, we have the countries, and as well our metadata information. So with that we have cleaned up the data for the location. Okay, so now what are the different types of data transformation that we have done here? Is first we have handled invalid values, so we have removed the minus with an empty string, and for the country we have done data normalization, so we have replaced codes with friendly values, and as well at the same time we have handled missing values by replacing the empty string and null with not available. And one more thing, of course, we have removed the unwanted spaces. So those are the different types of transformation that we have done for this table. Okay guys, now keep the energy up, keep the spirit up. We have to go and clean up the last table in the bronze layer. And of course we cannot go and skip anything. We have to check the quality and to detect all the errors. So now we have a table about the categories for the products, and here we have like 4 columns. Let's go and start with the first one, the ID. As you can see in our integration model, we can connect this table together with the product info from the CRM using the product key. And as you remember in the silver layer, we have created an extra column for that in the product info. So if you go and select those data, you can see we have a column called category ID, and this one is exactly matching the ID that we have in this table, and we have done the testing, so this ID is ready to be used together with the other table, so there is nothing to do over here. And now for the next columns, they are string, and of course we can go and check whether there are any unwanted spaces. So we are checking for the unwanted spaces, so let's go and check. Select start from, and we're gonna go and get the same table like this here. And first we are checking the category, so the category is not equal to the category after trimming the unwanted spaces. So let's go and execute it, and as you can see we don't have any results, so there are no unwanted spaces. Let's go and check the other column, for example the subcategory, the next one. So let's get the subcategory and run the query. As well we don't have anything, so that means we don't have unwanted spaces for the subcategory. Let's go now and check the last column, so I will just copy and paste now. Let's get the maintenance, and let's go and execute, and as well no results. Perfect, we don't have any unwanted spaces inside this table. So now the next step is that we're gonna go and check the data standardizations, because all those columns has low cardinality. So what we're gonna do, we're gonna say select distinct. Let's get the category from our table. I'll just copy and paste it and check all values. So as you can see, we have the accessories, bikes, clothing, and components. Everything looks perfect. We don't have to change anything in this column. Let's go and check the subcategory. And if you scroll down, all values are friendly and nice. As well, nothing to change here. And let's go and check the last column, the maintenance. Perfect. We have only 2 values, yes and no. We don't have any nulls. So my friends, that means this table has really nice data quality, and we don't have to clean up anything, but still we have to follow our process. We have to go and load it from the bronze to the silver, even if we didn't transform anything. So our job is really easy here. We're gonna go and say insert into silver.erp px and so on, and we're gonna go and define the columns. So it's gonna be the ID, the category, subcategory, maintenance. So that's it. Let's go and insert the data. Now as usual, what we're gonna do, we're gonna go and check the data. So silver ERP px. Let's have a look. All right, so we can see the IDs are here, the categories, the subcategories, the maintenance, and we have our meta column. So everything is inserted correctly. All right, so now I have all those queries and the insert statements for all 6 tables. And now what is important before inserting any data, we have to make sure that we are truncating and emptying the table. Because if you run this query twice, what's gonna happen, you will be inserting duplicates. So first, truncate the data and then do a full load. Insert all data. So we're gonna have one step before. It's like the bronze layer. We're gonna say truncate table, and then we will be truncating the silver customer info. And only after that, we have to go and insert the data. And of course, we can go and give this nice information at the start. So first we are truncating the table and then inserting. So if I go and run the whole thing, so let's go and do it, it will be working. So if I can run it again, we will not have any duplicates. So we have to go and add this step before each insert. So let's go and do that. All right, so I'm done with all tables. So now let's go and run everything. So let's go and execute it, and we can see in the messaging everything working perfectly. So with that, we made all tables empty and then we inserted the data. So perfect. With that, we have a nice script that loads the silver layer. But of course, like the bronze layer, we're gonna put everything in one stored procedure. So let's go and do that. We'll go to the beginning over here and say create or alter procedure. And we're gonna put it in the schema silver, and using the naming convention, load silver. And we're gonna go over here and say begin, and take the whole code, and it is long one, and give it one push with the tab. And then at the end, we're gonna say end. Perfect. So we have our stored procedure, but we forgot here the us. With that, we will not have any error. Let's go and execute it. So the stored procedure is created. If you go to the programmability, and you will find 2 procedures, load bronze and load silver. So now let's go and try it out. All what you have to do is now only to execute the silver load silver. So let's execute the stored procedure, and with that we will get the same results. This stored procedure now is responsible of loading the whole silver layer. Now of course the messaging here is not really good, because we have learned in the bronze layer we can go and add many stuff like handling the error, doing nice messaging, catching the duration time. So now your task is to pause the video, take this stored procedure and go and transform it to be very similar to the bronze layer with the same messaging and all the add-ons that we have added. So pause the video now, I will do it as well offline, and I will see you soon. Okay, so I hope you are done. And I can show you the results. It's like the bronze layer. We have defined at the start few variables in order to catch the duration. So we have the start time, the end time, batch start time, and batch end time. And then we are printing a lot of stuff in order to have like nice messaging in the output. So at the start we are saying loading the silver layer, and then we start splitting by the source system. So loading the CRM tables, and I'm going to show you only one table for now. So we are setting the timer. So we are saying start time, get the date and time informations to it. Then we are doing the usual, we are truncating the table, and then we are inserting the new informations after cleaning it up. And we have this nice message where we say load duration, where we are finding the differences between the start time and the end time using the function dateDiff. And we want to show the result in the seconds. So we are just printing how long it took to load this table. And we're going to go and repeat this process for all the tables. And of course, we are putting everything in try and catch. So the SQL going to go and try to execute the try part. And if there are any issues, the SQL going to go and execute the catch. And here we are just printing few information like the error message, the error number, and the error states. And we are following exactly the same standards as the bronze layer. So let's go and execute the whole thing. And with that, we have updated the definition of the stored procedure. Let's go now and execute it. So execute silver.load silver. So let's go and do that. It went very fast, like fewer than 1 second. Again, because we are working on local machine, loading the silver layer, loading the CRM tables, and we can see this nice messaging. So it starts with truncating the table, inserting the data, and we are getting the load duration for this table. And you will see that everything is below 1 second, and that's because at Unreal projects you will get, of course, more than 1 second. So at the end we have load duration of the whole silver layer. And now I have one more thing for you do, let's say that you are changing the design of this stored procedure for the server layer. You are adding different types of messaging, or maybe you are creating logs and so on. So now all those new ideas and redesigns that you are doing for the server layer, you have always to think about bringing the same changes as well in the other stored procedure for the bronze layer. So always try to keep your codes following the same standards. Don't have like one idea in one stored procedure and an old idea in another one. Always try to maintain those scripts and to keep them all up to date following the same standards. Otherwise, it's gonna be really hard for other developers to understand the codes. I know that needs a lot of work and commitment, but this is your job to make everything following the best practices and following the same naming convention and standards that you put for your projects. So guys, now we have very nice two ETL scripts, one that loads the bronze layer and another one for the server layer. So now our data warehouse is very simple. All what you have to do is to run first the bronze layer, and with that we are taking all the data from the CSV files from the source and we put it inside our data warehouse in the bronze layer, and with that we are refreshing the whole bronze layer. Once it's done, the next step is to run the stored procedure of the server layer. So once you execute it, you are taking now all the data from the bronze layer, transforming it, cleaning it up, and then loading it to the server layer. And as you can see, the concept is very simple. We are just moving the data from one layer another layer with different tasks. Alright guys, so as you can see in the server layer we have done a lot of data transformations and we have covered all the types that we have in the data cleansing. So we remove duplicates, data filtering, handling missing data, invalid data, unwanted spaces, casting the data types, and so on. And as well we have derived new columns, we have done data enrichment, and we have normalized a lot of data. So now of course what we have not done yet, business rules and logic, data aggregations, and data integration. This is for the next layer. Alright my friends, so finally we are done cleaning up the data and checking the quality of our data. So we can go and close those two steps. And now to the next step, we have to go and extend the data flow diagram. So let's go. Okay, so now let's go and extend our data flow for the server layer. So what I'm gonna do, I'm just gonna go and copy the whole thing and put it side by side to the bronze layer, and let's call it silver layer, and the table name is going to stay as before because we have like one-to-one like the bronze layer. But what we're going to do, we're going to go and change the coloring. So I'm going to go and mark everything and make it gray like silver. And of course what is very important is to make the lineage. So I'm going to go now from the bronze and take an arrow and put it to the silver table, and now with that we have like a lineage between three layers. And you are checking this table, the customer info, you can understand, this comes from the bronze layer, from the customer info, and as well this comes from the source system CRM. So now you can see the lineage between different layers, and without looking to any scripts and so on, in one picture you can understand the whole project. So I don't have to explain a lot of stuff. By just looking to this picture you can understand how the data is flowing between sources, bronze layer, silver layer, and to the gold layer of course later. So as you can see, it looks really nice and clean. Alright, so with that we have updated the data flow. Next we're gonna go and commit our work in the Git repo. So let's go. Okay, so now let's go and commit our scripts. We're gonna go to the folder scripts, and here we have a server layer. If you don't have it, of course you can go and create it. So first we're gonna go and put the DDL scripts for the server layer. So let's go, and I will paste the code over here. And as usual, we have this comment at the header explaining the purpose of this script. So let's go and commit our work. And we're gonna do the same thing for the stored procedure that loads the server layer. So I'm gonna go over here. I have already a file for that, so let's go and paste that. So we have here our stored procedures, and as usual at the start we have as well. So this script is doing the ETL process where we load the data from bronze into silver. So the action is to truncate the table first and then insert transformed cleansed data from bronze to silver. There are no parameters at all, and this is how you can use the stored procedure. Okay, so we're gonna go and commit our work. And now one more thing that we want to commit in our project, all those queries that we have built to check the quality of the server layer. So this time we will not put it in the scripts, we're gonna go to the tests, and here we're gonna go and make a new file called quality checks silver, and inside it we're gonna go and paste all the queries that we have built. I just here reorganize them by the tables. So here we can see all the checks that we have done during the course, and at the header we have here nice comments. So here we are just saying that this script's gonna check the quality of the server layer, and we are checking for nulls, duplicates, unwanted spaces, invalid date range, and so on. So with that, each time you come up with a new quality check, I'm gonna recommend you to share it with the project and with the other team in order to make it part of multiple checks that you do after running the ETLs. So that's it. I'm gonna go and put those checks in our repo, and in case I come up with new check, I'm gonna go and update it. Perfect, so now we have our code in our repository. Alright, so with that our code is safe and we are done with the whole epic. So we have built the silver layer. Now let's go and minimize it. And now we come to my favorite layer, the gold layer. So we're gonna go and build it. The first step, as usual, we have to analyze, and this time we're gonna explore the business objects. So let's go. If you like this video and you want me to create more content like this, I'm gonna really appreciate it if you support the channel by subscribing, liking, sharing, commenting. All those stuff gonna help the channel with the YouTube algorithm, and as well my content gonna reach the others. So thank you so much for watching, and I will see you in the next tutorial. Bye.